Hello, integrated math students. Today we're going to be covering the Unit 1 activity. It's mostly about exponents and things of that nature, kind of following a lot of the exponent rules. So if you got through the rest of the unit and you understand the exponent rules, then hopefully this activity is not too hard. But if you can just follow along and do everything I do, and everything I write down, you should be writing down, and everything I tell you to write down, you should also be writing down. If you just try to follow along and do that, you're going to do great, and you're going to score well, and it'll make a lot more sense. So let's just go right into the activity. Hopefully you have it open already, and let's go ahead and get started. So I'm going to share my screen here, and when you see the activity like this, it'll say Integrated Math 2 activity, Unit 1, blah, blah, blah. You go ahead and click on that, and it should bring up a Google Doc. Now, you'll probably notice that you won't be able to edit it, but if you go to the right here and you click Use Template, it'll bring up another Google Doc, but this time it's in your drive. So in this case, you will be able to edit this. And this will be the one that you're going to submit to your teacher when you submit the activity. So let's go over the first few questions here. So go ahead and hopefully you have it open, but I'm going to read this aloud, and you can please follow along. Reviewing the work and reasoning of others is essential to learning. It helps you reflect on what you have learned or maybe need to learn, deepens your understanding, and improves your skill communicating your ideas. In this task, you will review the work of your peers, evaluate their answers, work, and explanations by applying what you know about the rules of exponents. Each time you reach a conclusion, provide a written justification that supports your ideas. Okay, so the first person here is Haley. Haley simplified x to the power of 3 times x to the power of 2, and she got x to the power of 5. Lacey simplified x to the power of 3 plus x to the power of 2, and she got the same result. So she also got x to the power of 5. However, the teacher told them that only one simplification is correct. So who simplified correctly? Well, in this case, Haley simplified correctly. The reason why is because when you're multiplying two powers, as long as they have the same base, then you add the powers. Okay? You would not be able to add these together in that same way. Okay? So we would write that down and make sure you write it in a complete sentence. Don't just write Haley. Okay? So we would write Haley simplified correctly. Because when you are multiplying, we can say two things that have the same base, you should add the powers. Okay. You could write it exactly how I wrote it, or you can write it in your own way. Just make sure you're answering in a complete sentence that makes sense, and also making sure to punctuate correctly. All right, please put a period at the end of your sentences and capitalize the first letter and all that sort of thing. All right, Kenji simplifies 3 to the power of 5 times 4 to the power of 5 and gets the result 12 to the power of 10. So you can see Kenji added the powers here, right? 5 plus 5. I got 10. And as we learned from Haley, that is what you're supposed to do. You're supposed to add the powers. However, this is a different scenario because notice the bases are different. See, he has the base is 3 here and then 4. So can we add the powers like that? So here he multiplied those bases and then add the powers. No, you're not allowed to do that. Okay. Darlene is not sure. Is Kenji correct? Justify your answer. So in this case, also keep in mind, for some reason, it's italicized when this box is italicized for some reason. So you can just click on this I here and then it'll be normal. But anyway, in this case, Kenji is not correct. Okay. And the reason why is because these two numbers, they have different bases. So in this case, you won't be able to combine them in that same way like we did before. All right. So Kenji is incorrect because in order to combine them where you're adding the powers, they would have to have the same base. Okay. So I want you to explain that in your own words in a sentence or two, just explaining that Kenji is incorrect because he added the exponents when you can't do that when they have different bases. Okay. Okay. Question 3. And again, this one's italicized, this box again, so we can click this. Italicized. Okay. Gerardo is simplifying expressions with very large exponents. He arrives at each of the results below. For each result, decide if he is correct and justify your answer using the definitions and rules of exponents. So you might not be able to see these. They're actually really small. But if you highlight it and then you increase the font size, I like to do that, and then it helps me see what's going on here. I'm going to go ahead and increase all these font sizes. It makes it way easier to read. But anyway, so here he has x to the power of 150 divided by x to the power of 50. Now, hopefully you remember that when you have the same base and you're in a fraction like that, you don't divide the powers, you actually subtract the powers, okay? So here, the answer should be x to the power of 100 because you should subtract the powers. So he did this one correctly. So for part A, we would say Gerardo did this one incorrectly. I guess I spelled that wrong. Okay, he did this one incorrectly. He should have gotten x to the power of 100. So he should have subtracted the powers instead of dividing. Okay. All right. Now for part B. Here, you have y to the power of 20 times y to the power of 41. So here they have the same base, a base of y, and we're multiplying them. So if you recall, we should add those powers. And he did, right? So Gerardo did this one correctly. So we would say that Gerardo did this one correctly because when you have the same base, you simply add the powers when you're multiplying. So if you're multiplying, you have the same base, you add the powers. So briefly explain that in part B, that Gerardo did this correctly because he added those powers correctly. Okay. And then part C, but I'm going to let you type out the result for part B on your own, okay? I gave you an explanation, but you can write it in your own words, please. For this one, we have 2m squared, n to the 15th, and then this whole thing to the power of 3. So what this means is that everything in the parentheses is going to get to the power of 3. So the answer should have 2 to the power of 3, m to the power of 6, and the reason why is because when you have power to a power, you should multiply those powers. And then n to the power of 45. Again, n to the 15th to the power of 3. You power to a power, you multiply those. So you should have m to the 6th, n to the 45th, but this 2 also should get to the third power. But you can see in his answer, he didn't do that, right? He forgot to do the 2 to the power of 3 here, okay? But the m and n are both correct. So we could say Gerardo forgot to put the third power on the 2. However, he did do the m and the n correctly. However, he correctly applied the third power to the m and n. Again, don't forget to answer for part B. Okay, remember he did this one B correctly. Okay. All right, let's go to the next section. Once you're done with that, you can pause the video at any time, by the way, and go ahead and finish what you need to, or you could finish it all at the end once we're done with the rest of the activity. But either way, it's fine. Okay, task, E equals mc squared. All right, so please follow along as I read aloud. E equals mc squared is one of the most recognizable equations in the world. You've probably heard of it. Published by Albert Einstein in 1905, the equation describes a fundamental relationship between energy, E, and matter, or mass, M. But what exactly is the relationship? What does it mean? In this task, you will parse or analyze the parts of the equation in order to understand it better. Let's start with what the variables represent. E is for energy, M stands for the mass, and C stands for the speed of light. Use these definitions to complete the exercises below. Okay, so number 4, rewrite the equation to solve for the speed of light C. Use rational exponents instead of roots. Okay, so what we have is E equals mc squared, and what we want to do is get C by itself. So we want to solve for C. Now, what I would suggest is in these ones, I really want you want some math stuff on here. So we're going to use the equation editor. Okay, now how do you do that? So if you look at your toolbar and you look at insert, so let's click on insert, and if you look down, you should see equation. It has a pi squared and it says equation. Let's go ahead and click on that. And you should see your cursor is now in this like box. Okay, and what this is going to allow us to do is write equation. So let's start by writing our beginning equation, E equals mc squared. All right. Now, when we type in here, it will make it much more mathy looking. Okay. E equals mc. And then when I want it squared, what you're going to have to do is if you look on your keyboard, you should see the number 6 has like a little caret symbol. So if you hold shift on your keyboard and then press 6, it should put your cursor into the exponent of C, and we put a 2 there. So you should be able to, so make sure you're able to write this out, E equals mc squared. Now, if you're like me, this is kind of a small font, so let's go ahead and highlight that, and we can put plus, 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 and that makes it look much easier to read, much easier. Okay. So once you got that, let's move on to the next step. We want to get C by itself. So what would we do first if I'm trying to get C by itself? Well, I would try to get rid of M. And the way you would do that is by dividing by M on both sides. Divide by the mass on both sides of the equation. So what would that look like? So let's go and press enter. And we're going to use the equation editor again. So we're going to do a new equation. Okay, so you can see on the toolbar, this equation editor already popped up. So I clicked on new equation, and you can see my cursor is now in this box here, again, using the equation editor. And so what I want, since I'm dividing by M on both sides, the left side of the equation will be E over M. So it's going to be a fraction. Now, if you look at this equation editor, there's a bunch of tools up here. And if you look at this math operations tool, you go and click that, and you can see the very first one is a fraction. So we can click that, and it would be E over M. So the way you get into the denominator is by pushing the right arrow. So push the right arrow, and it puts you in the denominator here. So we want E over M. Press the right arrow one more time, and that push the right arrow one more time, and then that'll put you on the right. So now we're still in the box, but we're to the right of the fraction. So we can put equals, and then we'll have C squared. C squared. Okay. And again, I'm doing squared by holding shift and pressing where 6 is, where that 6, you see there's a little caret. So shift, press 6, and it'll put you in the exponent. Then press 2. Okay. Press right a couple more times, and it'll pull you out of the equation editor. Again, this is a little small for my taste. I'm going to go ahead and increase that size a little bit. Maybe I'll increase this one too. So right now I'm using font 22. I think that looks pretty good. Sorry, it's easy to read. It's easy to see what's going on. Okay, now let's get c by itself. Now it says to rewrite it using rational exponents instead of roots. So normally I would say, oh, take the square root on both sides to get rid of the squared. But since they're saying use a rational exponent, what we want to do is to the power of 1/2. Because when we do c squared and then to the power of 1/2, that'll just give you c by itself. It'll cancel out the squared. So we're going to do both sides to the power of 1/2. So what would that look like? So again, I'm going to use the equation editor, new equation. I'm going to do my fraction here, but before that, I'm actually going to use parentheses. So I'm going to use parentheses, and in that parentheses, I'm going to do a fraction. And again, it's e over m. So capital E, press right once, and that puts me in the denominator, over m, press right again, and press right again. Now I'm outside this exponent. So I'm going to do to the power of, I want to do to the power of 1/2. So I'm going to, again, use a fraction. So I'm going to go back up here, click on A over B here, and then 1, press right one time, 2. See how that looks really nice? E over m to the power of 1/2 equals, whoop, I'm going to have to press right a couple times there, equals c. So now c will be by itself. And that's what we wanted because it said we wanted to solve for c, get c, solve for the speed of light, c. Okay, so there's like that. Okay, I know that one took a while, but the next one hopefully is going to be a bit faster. All right, question 5. Using the properties of exponents, apply the rational exponent to the numerator and to the denominator of the fraction from your answer in part 4, then rationalize the denominator. So I'm going to go ahead and grab this one, just going to copy and paste. Okay. And we want to apply this 1/2 power to the numerator and the denominator of this fraction. So again, I'm going to use a new equation using the equation editor again, and I'm going to use a fraction again. On the top, we're going to, basically this 1/2 power is going to go to the numerator, to the e, and to the denominator, the m. So this will be, in my numerator, e to the power of 1/2. So again, I'm going to use a fraction, 1 over 2. So this should say e to the power of 1/2 on top. Press right, press right, press right. Now we're in the denominator of the big fraction. On the same thing, I want m. And then the m is also going to get to the power of 1/2. Remember, this 1/2 power goes to everything in the parentheses. So it goes to the e, the numerator, as well as to the m, the denominator. So I'm going to have to do the exponent. So that was shift, press 6, remember, to get the exponent. Use this, 1, press right, over 2. So I've got e to the power of 1/2 over m to the power of 1/2. Let's write a couple more times, and that gets us outside of this fraction. And then we'll just write equals c. Okay. Now the next step, it says to rationalize the denominator. And the way you would do that is by multiplying both top and bottom by m to the 1/2. Okay. And what that would do for you, essentially, I guess I'll just show you with some writing here. So if I have e to the 1/2 on top over m to the 1/2 on bottom, to rationalize the denominator, you'd multiply by another m to the 1/2. And whatever you do to the top, whatever you multiply on the bottom, you also have to multiply on top. So like that. So then you would rewrite this m to the 1/2 times m to the 1/2. Well, remember, if they have the same base, you can add those powers. So 1/2 plus 1/2 is just m to the 1, which just gives you m. And then on top, we have e to the 1/2 times m to the 1/2. Okay, so this is what they're looking for in the next step. Okay, so let's go ahead and do that. Should be e to the 1/2 times m to the 1/2 in the numerator of this fraction over m in the denominator. Okay, so we're going to press enter here, and again, new equation. Okay, so and again, I'm going to do a fraction. And then on the top, it's going to be e to the power of fraction, 1/2, 1, press right, 2, press right, m, whoop, press right one more time, m to the power of 1/2, press right, press right, press right, press right. Now we're in the denominator of the big fraction. And now here will just be m. Press right one more time, and we'll say that equals c. Okay. Do you see how we use the property of exponents to apply the rational exponent, e to the 1/2, to both the numerator and denominator, and then we rationalize the denominator. So rationalizing means we're not going to have any fractional powers in the denominator or any roots in the denominator. Okay. Very nice. Looks very, very nice. And if you want to, you could always make these things bigger by increasing their font. Okay. That looks very nice. Okay. You could even maybe put some space in between your steps. It's maybe a little bit easier to read. Okay. Just as long as you make it easy to read, it's going to make it easier for your teacher to grade. Okay. Now rewrite the equation without writing it as a fraction. Okay. But you can have fractional exponents. I'm just actually going to go from this step, Control C to copy, like right here, Control V to paste. Okay. So just copied and paste this middle one here. This will be the easiest one to go from, I think. Now I'm going to rewrite this not without using any fraction. Okay. So, well, what's another way I could write m to the 1/2 here in the denominator? Well, remember, if you have a power in the denominator, let me clear this. Just make it new. So if you have e, let's just recall, before I go over this, let's recall the rule. So if I have, let's say, x to the power of something, let's just make it 5, over x to the power of 2. Now what you can is you can rewrite this x to the power of 2 as this x to the power of 5 stays the same, and then times x to the power of -2. Okay, so having a power in the denominator, you could rewrite it as no longer a fraction by putting it as a negative power. Okay, so in other words, when we see this one here, we can rewrite this as e to the 1/2 times m to the -1/2. Okay, again, pulling that power from the denominator will make it a negative exponent. Okay, so that's what we're going to write, equals c. So that's what we're going to write for this one. So let's go ahead and press enter, enter, and let's do a new equation. Then we're going to write e to the power of, so I hold shift, press 6, that gives me the exponent, to the power of 1/2. So I'm going to go back up to here, press 1, press right, press 2, so I've got e to the power of 1/2. I'm going to press right, and then press right one more time. Then m to the power of, so shift, press 6, power of -1/2. So I'm going to do a negative first, and then do 1/2 here. So 1, press right, press 2, press right, equals c. Just like that. Okay, look how nice that looks. Okay, great. Number 7, using whichever equation you prefer, either the one we got from part 4, part 5, or part 6, find the speed of light in meters per second if a 3 kilogram mass of matter converts to 2.7 times 10 to the 17 joules. No, joule is a measure of energy, so that'll be our E. 1 joule is the amount of energy needed to move 1 kilogram of mass at a speed of 1 meter per second. Okay, whatever. Okay, so this 2.7 times 10 to the power of 17 joules. That's actually a very large number because to the power of 17, that means 10 to the power of 17, that means 10 times 10 times 10, 17 of those in a row, right? So that would be a 1 with 17 zeros. It's a big number. Then times 2.7. This will be our energy. So this will be the variable E. So here we're going to say, and again, I'm going to use my equation editor here, and I don't want it to be italicized. So make sure we click off that. So we have, and we're going to increase the font like we did before to 22. So I'm going to do that for this entire box. So I'm going to highlight this box. Yeah, highlight the box. And we're going to do to the font 22. And we don't want it italicized. Okay. So equation. And I'm just going to say that the E equals, and in our case, it's 2.7 times. We could use that as times, or you could use, we can maybe go into here. Will there be, we could use this times. Okay. And then 10 to the power of 17. So that's one piece of information we have. And we also have the mass. See, notice it says a 3 kilogram mass. So our M, our mass, so equation editor, our M will equal 3 kilograms. You should put 3. That's fine. Okay. Then from here, we're actually, I think the easiest equation to use is probably this one that we got in part 4. So I'm just going to go ahead and take that. I'm going to copy and paste. So Control C to copy, and then Control V to paste. And so what we're going to do is we're going to replace E and M with our two values that we got right here. So instead of E, we're going to replace that. So I'm just going to actually, let's just go. I'm going to copy this again. We're going to copy, we're going to paste, and we're going to replace E with what's up here. So that's 2.7 times 10 to the power of 17 over M. What's our M? 3. Okay, M is 3. Okay, we should be able to calculate what the speed of light is by using this. Okay, so the first thing we would do is 2.7 times 10 to the 17th divided by 3. So in our calculator, we actually don't need to calculate it much. What I would just do is the 2.7 divided by 3, and that should give you 0.9, and it'll still have 10 to the power of 17. So what this will equal, and let's just use our equation editor, it'll be now just 0.9, because I did 2.7 divided by 3, times 10 to the power of 17. Press right. 10 to the power of 17. Press right. Close parentheses. And then this needs to be the power of 1/2. I'm going to put, instead of 1/2, I'm going to put 0.5. But know that that's the same as 1/2. Okay. Equals C. Okay. So now notice we have 0.9 to the power of 1/2, or a power of 0.5. So let's figure out what that is. So what's 0.9 to the power of 0.5? I can use my calculator again. 0.9 to the power of 0.5. Okay. What that gave me is, let's see, 0.9. Okay, 0.9487, we'll say. So this will be 0.9487, roughly. I should be using the equation editor to make it look nice and mathy. 0.9487, and then times 10 to the power of Remember, we have power to a power. We multiply those powers. So what's 17 times 0.5? That should be 8.5. Yep. 8.5. Okay. Then we multiply those together. So we have 10 to the power of 8.5, and then times 0.9487, roughly. So you should get about 300 million. So this is approximately, and notice this, I can use approximately symbol right here. Oh, look how nice that looks. Approximately 3 1, 2, 3, 6, 7, 8. Okay, I'm going to put some commas here. Approximately 300 million, and what we're actually going to call this is meters per second. Okay, meters per second. So we're going to put m per s. Okay, that's the speed of light, by the way. It's 300 million meters per second, which is a speed that most people can't comprehend, including myself. So anyway, that's roughly the speed of light. Great. Okay, well, I hope that all made sense. I hope you're able to follow along. And if you have any questions, you can feel free to email me. And my email is ttrigg@ofy.org. And with that, I'll see you guys next time. Take care.